Come here, little guy. Now that the units are on the grid and we can select them, it's finally time to select them and tell them where to go. So that's what we're gonna do today. Let's get to it. So in Unreal, the first thing we're gonna need is a way to know which tiles the unit can walk on and also if the unit can walk diagonally. So what I'm gonna do is just add some data inside the structure of unit data. And this is in Blueprint, Core Units, and Utilities right here. And I'm actually just going to create another structure, the same way we did for the asset. So create a new structure right here. I named the structure s_unit_data_stats, and it is going to contain all the stats of the unit. So the action points, movement points, HP, damage percent, critical chance, everything. And it's also going to contain all the data letting us know how the unit is going to move on the grid. So in there, I created myself two new variables. I have one that is an array of e-tile types, which I named valid tile types. And then I have a boolean that I named can move diagonally. And now with those two variables, we now know how the unit is going to move on the grid and also which tile types are valid for it. And finally, just before closing the structure, I added myself three new array elements in the valid tile types because in my case, most units are going to be able to walk on the normal tiles, the double cost and the triple cost, so I just set them as default, but it's not required. Now I'm just going to save that and close it. And now we need to add this structure inside the SUnit data to be able to edit it in the data table. So I'm just going to open that one, create myself a new variable for the new structure. So the variable is of type SUnit data stats, and I just named it stats. Now I can save and close the structure and go inside the data table to set all the default values for all my units. And in this case, I didn't change much because I already had my three default valid tile types in all my units, but I made sure that my ranger can move diagonally just so we can test it. And I've also changed the chicken so it's moving diagonally also. And I've changed my bat so it can fly over the flying units only tile, just like that. And that's it. Now we can save and close the data table. And now that we have some new data to assign to the units, I'm just going to go change a few things in it. So I'm gonna go in my Blueprint, Core Units, and open BP Unit right here. And I'm gonna go directly inside the construction script. And this is where we are applying the data. So what I'm gonna do is just select all that and collapse it into a function. So collapse to function that we can bring a little bit closer. And now inside the function, we're gonna do a few little changes. And the first thing I changed is the name of the function and also the name of the variable. So now the function is named setUnitData and the variable is named data. And now what we want to do is save that data inside the variable in the unit. So I'm gonna right click on it and do a promote to variable right here. Just like that, so I renamed the variable unit data and it is now saved inside the unit blueprint. And while we're here, I'm just going to go remove the test anim index that we created. So that was used in the event graph right here. So I'm just going to remove all this. And actually, before doing that, I'm just going to delete those and collapse this into a function because we're going to do that a few times. And I think it makes more sense to just have a function to do that instead of always doing it with three nodes. We're just going to be able to call one function. So I'm just going to right click, collapse to function. Now that I have my function, I'm just going to delete all this. And at the begin play right here, I'm just going to set my unit to idle. Now I'm just going to go inside the function to clean it up. And actually I didn't do much, I just renamed the function set animation state. Voila, now we can simply delete the variable that we don't need anymore. Perfect. And it's now time to go create the pathfinding action. So I'm gonna go back here and I'm gonna go in my core, in my action. So player action in the pathfinding right here. And I'm actually going to duplicate the find path to target because it's pretty similar. I named it the action_move unit on grid and then I'm going to open it, but I'm not gonna do anything right now. I'm just gonna go create the button first because we're gonna have a few parameters to pass later. So I'm gonna go create my button and then we can focus on the real logic. So in the button actions, I will do the same thing and duplicate the find path to target and rename it so it fits with the name of the action. So the name is button_action_move unit on grid and I'm going to open it also. And actually right here, I'm just going to keep one slider. So the two checkboxes are gone and that slider is gone. I'm not going to rename that slider right now because we're gonna do that later in the video. But for now, we can just keep it right here. We can compile and go fix the errors in the graph. And actually to fix them, I'm just going to delete everything I don't need. So right here, I can delete the two checkboxes and I'm going to keep only the slider that I kept in the designer. And then if I go here, I'm actually just going to delete this, keep only the sliders, so I can delete all that. I'm going to also delete the sliders from there and the old variable. So I only keep the new variable and the old slider. So I only kept the slider that I kept in the designer. And finally, I replaced the cast with the cast to the new action we just created. So the move unit on grid and just reconnected everything like so. And we're done with the button for now, so I'm just going to save it and go add it inside the tab Pathfinding. So let's open the tab Pathfinding, get the button on the left, so move unit on grid, and drag it inside the vertical box with all the other ones, give it 2 of padding, and that's it. I'm just going to close the tab, and I actually forgot to rename the button itself, so I'm gonna go back in the designer right here. I'm going to change the button, and I'm actually also going to change the left click and right click action. So left click action, it's still good, but the right click action is the move action that we created. So move unit on grid, and I'm going to change the name also. So the name is now select/move unit. Perfect. We can resave that and go in the action to do the real logic now. So what are we gonna do here? Let's go in the execute action to see what we're gonna do. Right here at the end, what interests us is the find path function right here. And here it is using the include diagonal that we have in the variable, but we don't want to do that. It's using the tile type that is inside the variable also, but we don't want to include that. We're just going to use the data that's coming directly from the unit, and actually these two are just going to be deleted because we're not gonna need them. So let's just do that real quick. And that's how we're accessing all that data. So in the player action, we are getting the selected unit, and then we can fetch its data, break the structures, whatever, and then we can connect the valid tile type to the tile types and the diagonals to the diagonal, just like that. And for the delay and the max milliseconds, we don't care about those, so we can just leave it 0 for now. Perfect. But here we're gonna have a bunch of errors if the unit is not valid, so we're just going to have to make sure that the unit is valid before doing all that. Otherwise it means that we don't have a unit selected and we can't execute the action. So we're just gonna go right here at the beginning, right before binding ourselves to the event. We can simply do an is valid on the unit, just like that, and connect it like so right here. That way, if the selected unit is valid, we're gonna try to move it, otherwise we're not gonna do anything. And now that all that is done, we're not gonna need all those 4 variables anymore. So we can just delete them, delete, and delete. Perfect, we can now compile, and we can go do the next part, which is the on pathfinding data completed. So right here, because we found the path, it is complete. Now we just have to tell the unit to move following that path. But before doing that, I'm just going to move this a little bit out of the way and use the variable instead of the input directly, just like so. Then we just have to make sure that the selected unit is still valid before doing all that, because it's possible that the selected unit is not valid anymore in the case that it took too much time to generate the path and now the user selected another unit or something like that. So we have to make sure that the selected unit is still valid. So now we have a selected unit that is valid and we highlighted the path. Perfect. We just need to pass the path to the unit and tell it to move. So I'm just going to get my unit right here, and then we are going to call a function on it. So I'm just going to go back in the unit to create the function, and actually I'm just going to create an event instead, because the movement on top of the path is not going to return anything, and it is going to take multiple seconds for the unit to complete the whole path. So I think it makes more sense if it is an event. So custom event. I named the event event_follow path, and I'm passing it the path, which is an array of endpoint. And now we can just go back in the action and call it. So from the selected unit, we can call the event follow path, just like that, and then pass it the path right here after highlighting it, just like that. Perfect. And now we can finally go back inside the unit to do the movement. And here the first step is to make sure that the path that we receive as input is greater than 0, because we don't want the unit to move on a path that is empty. And then if the path is valid, I'm just going to promote it to a variable, because we're going to go through the path one by one, and we're actually going to remove all the elements that we already processed. So that's why I'm setting it inside a variable, that way we can reuse it later and modify it. And for the variable name, I named it current path to follow. And now that we set the path, it's the time for the unit to move on it. So I'm just going to start by changing its animation. So I'm going to take that function and paste it right here. And we're going to make sure to change the animation state to walk instead of idle, because the unit is now walking on the path. And now to move the unit, we're just going to use a timeline. So I'm going to right click and search for add a timeline, just like that. And this is going to let us interpolate between the first point and the second point, and then the second point to the third point, and etc. And here I'm just going to start by renaming the timeline. You can do that in the top right corner. So timeline unit movement. And then we can compile just to save the name. And if it is the first time you're using a timeline, you probably don't know what it is, and actually if you double click on the node, it opens a new window, and it is a window that contains multiple curves of animations. That way we can animate the unit movement with a curve. It's way better than just interpolating it with numbers and things like that. It's way faster, and I think it makes more sense. But yeah, if we want to add a curve in there, we have to click on one of those buttons right here in the top left corner. But before doing that, I'm just going to change the length of my animation to 1 second instead of 5 seconds. And then I can just create a float track. So the first one, it is a float track, just create that one. And now we have an empty track, but before adding anything to it, I'm just gonna start by renaming it. So rename the track, and I'm going to name it the location alpha, because this is going to be the alpha of the location of the unit on top of the grid. And by that I mean this is the unit progression percent from one tile to another. That way we'll be able to easily animate its movement only based on one simple float. And now that the track is named properly, if we go back in the event graph, we should see that we now have a new pin in the function right here, and it is the same name as our track because it's going to be the value of the curve at the current time of the timeline. So if the timeline is at 0.5 seconds, for example, this value that we are going to receive right here is going to be the value of the curve at 0.5 seconds in the track. But right now, since the track is completely empty, this value is never going to be updated, so we're just going to go back in the timeline and create a few keys to modify that value. And to do that, I'm just going to do right click, add a key to curve float, and then I'm going to do it a second time. So right click, add key to curve float. And then for the values of the key, I'm just going to select it. And for the first one, it's going to be 0 and 0. So it starts in the bottom left corner completely. And for the second one, it's going to be 1 and 1. So it's going to be a value from 0 and 1 right there. And it is going to be a straight linear position, just like that. We can make it a little bit more curvy in the future if that's something that we want to do. And that's it for this timeline for now. It's as simple as that. Now we can go back in the graph and use it to move the unit on top of the grid. And to do that, we're going to use a set actor location and rotation. I know we're not doing the rotation right now, but let's ignore that for now. We're going to do it a little bit later. So we can connect that inside the update. So every time the timeline gets updated, we are going to set the new location and rotation of the unit based off the value that we received from the timeline. And actually, since we are passing an alpha and not a location directly, we're going to use it to interpolate between two locations. So what I'm going to do is drag from the new location right here and search for lerp vector. That way we can interpolate between the previous tile and the new tile. And we can connect the alpha just like that. And now to be able to interpolate, we're gonna have to feed it the position of the current tile and the position of the next tile. But since we are actually going to interpolate both the location and the rotation, I'm actually just going to simply create two new transforms. So variable 1, variable 2 for both transforms. I named them previous transform, which is a transform, and also next transform, which is also a transform. And the current unit transform is going to be somewhere in the middle of both transform based on the timeline progress. So if we are at 0.5 in the timeline, we are going to be exactly at 0.5 in between both transform. If we are at 0.99, it's going to be even way closer to the next transform than the previous transform. And we are going to set both of them just before calling the timeline like that. So we are setting those two transform and then we are interpolating in between them. And now to set those two variables, we're going to start with the previous transform because it's super easy and it is simply to get the actor transform of the unit because the unit is currently on a tile, so we are getting its transform and then we're going to interpolate between that current position and the next position where we want to be. And for the next transform, it's going to be a little bit more complex because we need to know where the next tile is in the world. And to do that, we actually need to have access to the grid, which we don't right now. So I'm just going to create a new variable for the grid. I name my variable a grid and it is of type BP grid, obviously, and just before going to set it, I'm just going to use it right here just so we set the next transform. So we are getting the grid tiles from the grid, we are getting the first index of the current path to follow. So the index is 0, then we find it from the grid tiles to access its transform and setting the next transform where we want to go. And now that both transforms are set, we can simply access them. So we can get them and split them right there to have access to both locations. And then what we can do is just pass them to the vector, so like that. We can lerp between the first location to the second location, and that should work. But before being able to test all that, we just have to remember to go set the grid, because right now we just created an empty variable and we're never setting it anywhere. So to do that, I'm just going to create a new function real quick to set the grid. I simply name the function setGrid and I'm passing it the grid to set the variable just like that. And we're gonna go call this function where we are placing the unit on top of the grid, which is in the combat system. So I'm just gonna go in the combat system, open that one, and go in my function add unit in combat right here. And I'm just calling the function right here at the end. Perfect, we should now be able to compile and go see how it looks in game if it actually works. So here I'm just going to add a unit on the grid just like that, and then we can select and move it. So I'm just going to try to move it right here. Okay, the unit moved, okay, it's walking, but at least it worked. It moved to the first place. Okay, that's interesting. We have a start. Yeah, that's good. We are interpolating between the start tile and the next tile, but then we have to do the same thing for all the other tiles. So once we are done interpolating to the first one, we have to interpolate to the next one, to the next one, to the next one, and over and over and over until we reach the end of the path. So that's what we're gonna do now. So let's just stop and go back in the BP unit where we are using the timeline just right here. And it's actually not that difficult to do. We just have to, when the timeline is over, so when it is finished right here, we just have to remove the first index of the path, just like that. Because we already processed that one, we're done, we're gonna go to the next one, and to do that we can simply reconnect all that all the way here at the beginning. It's not pretty, we're gonna fix that in 2 seconds, but I think it's going to work as a proof of concept, so now we can just go try to see if it works. I'm gonna re-add my unit on the grid, and now I'm gonna try to move it and click right there, and now we can see that the unit is walking and following the whole path. Here we go, the unit is walking to the end of the path. Yay! It's super slow. Here we go. Okay, reaches the end. Oh, okay, it broke. Yeah, that's good. And now I have a bunch of errors because the list is empty and now the unit is trying to move it on top of an empty list, and that's not good. So we're gonna fix that also, and we're gonna do all that by moving everything inside another function just so it's a little bit more clean and also more clear. And to do that, I'm actually going to move a bunch of code around, so follow me. We're gonna do that right here at the beginning. I'm gonna start by creating myself a new event, which I named continue to follow path. And then once we remove the index, instead of going back to the previous transform right here, we're just going to disconnect that and call the new event, so continue to follow path, just like that. Then our event is going to make sure that the path is not empty and that we still have something to iterate through. So I'm just going to make sure that the length is greater than 0 before going to the next iteration. And well, if that's true, well, it means that we just have to continue walking along the path, just like that. We're gonna continue the next loop, but otherwise we're done walking. So I'm just going to copy paste the animation state right here, and then instead of setting it to walk, I'm going to go back in idle, because we're done walking, we're done looping through the whole path completely, and we reached the destination. And that should be enough to fix all of our problems. I'm just going to do a little pass of cleanup. So I'm just going to move this right here and then place that back at the end. And then instead of connecting it like so, I'm just going to call the continue to follow path function right here. That way it's going to call the events that we have right here. So we are following the path, continue to follow path, which is going right there, and then starts to walk, do the timeline and everything else. I'm just going to move a few things around just to make it a little bit cleaner. Here we go, that's not the cleanest, but I wanted to fit as much as possible on one screen, and now we can go test it to see if it fixed the problem. So I'm just gonna go in my pathfinding, add a unit, move the unit on the grid, and now the unit is moving, it's moving, it's moving, it's moving, it reaches the end, et voila, it's going back in idle. Now if I try to move again, it goes back from the beginning of the path, which is not good, so we're gonna have to fix that, but we also have to fix the rotation of the unit, because right now it's not looking where it's going, it's just going backwards in there or sideways, and it's pretty weird, so we have that to fix also. So we have a few little things to fix. I'm gonna fix the rotation first, and then we're gonna fix the path starting over and over from the beginning. So let's go back in there to fix the rotation. And to do that, we're going to use a look at, because we want the unit to look at the next tile where it is going. So I'm going to start by disconnecting the next transform and splitting it to have access to both the location and rotation independently, just like that. And then we can reconnect the location just like this. And then we're gonna do the look at, so we're gonna look where the unit is going. So it is going from the previous transform, so I'm just gonna get the previous transform, split it, and connect the location as a starting point, and then the target is where we are going. So look at the location of the target index, just like that, and then we can connect that back to the set transform just right here. And then we're gonna go apply it right here where we are setting the actor location and rotation. And to do that, it's pretty simple. We just have to do a lerp of rotator between the previous rotation and the next rotation right here. And then we can feed that inside the set actor location and rotation right here. Just make sure to check the shortest path checkbox, otherwise it might have some weird behavior. And then we just need to feed it an alpha, which we don't have right now. So we're just gonna go back in the timeline just to create a new track for the alpha of the rotation. So let's go in there. And here I'm going to create myself a new float track, which I'm gonna rename rotation alpha. Then we're gonna add 2 points in the curve, just like that. And we want the unit to turn faster than it is moving because we want it to start looking at where it wants to go before reaching it completely. So that's why we have 2 different curves. And the first one is going to be 0, 0 because it's going to start rotating right at the beginning. And for the second one is going to be, let's say, 0.6 and 1. So once we reach 0.6 seconds, right now the unit is going to be completely looking at where it is going. And finally, just so the animation is a little bit smoother for the rotation, I'm just going to select both keys like that and then right click on them and choose auto, so it makes it a little smooth in the curve, just like that. And now we can go back in the event graph just to connect the alpha. So I'm going to take my rotation alpha and connect it like so. I can add a reroute node just so it's a little bit cleaner because it's getting already a little bit messy. And now we're going to go test it. So I'm going to go back in entry, press play right here. I'm going to add the unit on the grid and then I'm going to try to move it. So move. Here we go. The unit, okay, rotates and then starts to walk again. Okay, I'm just going to make a shorter path. So yeah, the unit is rotating. When it reaches a corner, here we go, we can see that it is looking where it wants to go. Great, it works. But now the animation is super slow, so I'm just going to go speed it up a little bit, and that's why we add a slider right here to be able to change the animation speed because the path progress it takes way too long to reach the end. So I'm just going to add the value in the slider so we can modify that in runtime. And to do that, I'm going to start by going back in the unit to create the new variable we're going to use. I named the variable move duration per tile because it is the time required to reach from one tile to the other, and it is a float and the default value is 1 because it is the length of the timeline. And we're gonna use it to affect the play rate of the timeline, so it's either faster or slower. And to do that, we can first start by accessing the timeline, so get the timeline unit movement, just like that, and then we can do a set play rate. And that's how we're going to connect it. So before calling the timeline, we are going to set its play rate based on the timeline length, so currently 1 second, and then dividing that by the amount of time we want to spend in that timeline. And now we're going to go set the variable inside the action right before calling the follow path event right here. So set the variable, set the move duration per tile right here. Here we go, and now I'm going to promote that into a variable so we can set it in the user interface. So new variable. I named it move duration, and now we can go hook that up inside the action right here. And we can simply connect it like that using the value of the spin box that was remaining in the user interface. So now I'm going to go in the designer just to tweak the spin box itself to change the name and the values. Here we go, so now I renamed it move duration, and I've also changed the text written on it so it's moved there, and then I've changed the min-max value to 0.01 and 2 because 2 seconds it's already long, so we don't really want to go further than that. And 0.01, actually 0.001 will be better, so 0.001 just to make sure that it is not equal to 0 because we can't really divide by 0, so that's not what we want to. Then for the default value it's going to be 0.25 because I think it makes sense. Min-max digit are gonna be 3 and 3, and then the delta is going to be 0.001. And I guess that's it, so now we can compile and go test in game to see if we can change the speed at which the unit is moving on the grid. So now I'm going to select my unit and try to move it. We can see, okay, it's already faster with the 0.25 speed, and now if I make it like 2 seconds, let's say for example, yeah, now it takes forever to reach the next tile, okay? And now we can bring it back down. Here we go. It's similarly as the previous one, and now 0.1, vroom, vroom, vroom. We can see that the unit moves super fast. Here we go. So now you can decide at which speeds you want the unit to move on the grid. Perfect, we're done with that. Now the only thing we have to fix is to make sure that we update the position of the unit when it is moving, because right now we are not updating it. It's just the visual that is getting updated, but the real position of the unit is not updated in the data, so we're just going to go fix that. And the first step to do that is to add a callback inside the unit so we can notify everything else in the game when the unit moves on the grid. So I'm just gonna go back in the unit and create a new event dispatcher. I named it onUnit reach new tile, and I'm passing it two inputs, so one for the unit and one for the new index. And we're going to call this new callback every time the timeline is completed. So right here, before removing the index from the list, we are just going to call the new callback just right here, passing it the new index before we remove it from the list. And now that the callback is called inside the unit, we can go inside the combat system to hook ourselves to it. So I'm gonna go back in the combat system where we are adding the units in the combat, and right after adding it to the combat and on top of the grid, we're just going to call the new callback right there. We're gonna hook ourselves to the new callback, so event onUnit reach the new tile, and we're gonna do a create event. Right now I don't have any function, so that's why I have an error, so I'm just going to make create a matching function, just like that. I named it onUnit reach the new tile, and I'm simply using it to call the set unit index on grid function. Later, right here, before calling this function, we might want to have some verification to make sure that the unit was able to reach that tile, or maybe add some other checks to make sure that the unit didn't step on a trap or something like that. But for now we don't have any of these, so we can simply just set the new index and assume that the unit moved on a valid index. But now, even though the index of the selected unit is updated in the data, it's not going to work because we're never updating the selected index. So we're also gonna need to update the selected index every time the unit moves on the grid. We could probably hook ourselves to the same callback, so the onUnit reach the new tile callback, but I think it would make more sense to create a new callback inside the combat system. That way we could have some extra verification right here before setting the real index to the unit, and then we can hook ourselves to the real callback and not the movement callback that was called inside the unit. And that's why I'm going to create myself a new event dispatcher right here in the combat system. I named it onUnit grid index changed, and I'm passing it the unit, and we're going to go call that callback inside the set unit index function right here. And we're only going to call it in the case that we are setting a new index, so right here at the end of the sequence. So we can just call it right here and pass it the unit just like that. So now everything else in the game can hook itself to that callback every time one of the unit gets updated. And that's exactly what we're gonna go do in the player actions. So I'm gonna go in the player actions, and I'm gonna go in the event graph right here. We are setting the combat system, so we're gonna do the same thing and hook ourselves to the callback right here at the same time. So bind event to onUnit grid index change, and with the create event we can create a matching function. I named it onUnit grid index changed, and for the logic it's pretty straightforward. If the unit in which the grid index changed is the same as the currently selected unit right here, we are just going to update the index. So I'm gonna take the new index of the unit and then set a selected tile and unit right here. And that's it, we should now be able to test. And now with a unit on my grid, I'm able to select it and move it around. So the unit moves, we can see that it updates the selected tile right under the feet of the unit, like so. And if we click to generate a new path in between the unit walking on the current path, we can see that it updates the path and the unit doesn't reset. It continues from where it is. Perfect, we are now able to move the units on top of the grid. But it's not exactly perfect. We still have a few things to fix before completing this video. And the first one is actually, I think it would be nicer to just make the path disappear once the unit is done pathfinding. So we're just gonna do that first. And to do that, we're gonna go in the unit, create another callback. So let's create another event dispatcher. I named it onUnit finished walking, and I'm passing it the unit as input. And we're gonna go call this callback once we're done walking completely. So right here when we are going back to idle. So let's call the callback right here, and we can pass self as unit because this is the unit that was done walking on the grid. Perfect. And now we're gonna go hook ourselves to that callback inside the action move unit on grid, because this is the action that displays the path on the grid. And actually, since we're here at the same time, I'm just going to make sure that this action is always executed on the same unit. And actually, by that I mean the second part of the action should always be executed on the same unit as the first part. So in the case that we selected a unit and decided to tell it to move, if the pathfinding was completed, let's say 10 seconds later, in the meantime, if you deselected the unit or try to select another unit, we should not execute the second part of the action because the unit changed, so the context is completely different, so we should not execute that second part in the case that the unit changed in between. And obviously this can only happen because it is possible to set a delay and a max milliseconds here when we are finding the path. If we always set those values to 0, it should not be a problem because this event is always going to execute itself immediately. But in the case that we add a delay in between iterations of the path, that way it will generate a longer delay between the moment that you ask it to generate the path and the moment where you are telling the unit to move on the grid. So this is where the problem can be in the case that you are using a delay. So to do that at the beginning of the execute action right here, we are checking if the selected unit is valid, and at the same time I'm actually just going to promote it inside a variable. So right click on it, promote it to variable. So here we go, I'm taking the selected unit and setting it inside my new variable, which I named the current unit, and that's the variable that we're checking to make sure that it is valid, and it is also the variable that we're going to use everywhere. So I'm just going to go see everywhere else that we were using the selected unit. So right here, for example, I'm going to replace it by the current unit just so it makes sense. And then that's it for this part right here, and then we're going to go see the on pathfinding completed just right here. And here we're going to replace the selected unit just right here, so in the is valid like that, and then we're gonna do the same thing at the bottom right here. So replace the selected unit by the current unit. And now this brings us to the part where we are checking if the current unit is still the same as the first part of the action. So in the first part of the action we are setting the current unit. Now we're just going to compare to make sure that the selected unit is still the same as the current unit. And we're going to do that just like that. So we're just going to do a little branch right here where we are comparing the current unit with the selected unit in the player action. That way all this code right here is only going to be executed in the case that the selected unit didn't change since the first part of the action. Bon, that was not really planned, but now it's time to go back on what we were doing and try to hide the path once the unit is done walking. So I'm just gonna go back in the execute action function right here where we are setting the current unit. We're gonna hook ourselves to the callback just right here. Just like that, so I'm taking my unit and binding it to the unfinished walking callback, and for the event we can just create a matching function, which I named the onUnit finished walking, and the logic is pretty straightforward. We just have to make sure that the unit that we receive, so the unit that just finished walking, is the same as the current unit, and if it is the case, well, we can simply clear the path state from the grid, just like that. And now if I go back and see how it looks in game, I'm just going to press play, generate my grid, add some units on the grid, so a few units here and there, and now I can select my unit and move it. Once it's done moving, we can see that the path disappears completely because the unit doesn't need it anymore. And let's say in the meantime we select another unit and start moving it, we can see that it works properly and the units are now all working on the grid. They are working on the grid, no problem, perfect. But actually there's still a little bug. Right here I can select both my unit and move them if I want to. That's working perfectly fine. But what happens if the unit tries to walk through the other units? Well, first it can, and that's an issue. It should not be able to walk through another unit. That's a big problem. So we're gonna fix that. And at the same time, it's going to fix the fact that now I can't really select that unit because it's not really on the grid anymore because the other one kicked it out. So that's not good. So we're just going to make sure that the unit cannot walk through the other units during the pathfinding. It's going to walk around it just like that. And we're gonna go do that inside the blueprint of pathfinding. So I'm gonna go in my grid, in BP grid pathfinding right here. And we're gonna check if the unit right here that we can see just right here, the unit on tile is not valid when we are getting the tile neighbors. I'm in the right function, that's great. So in the function get valid tile neighbors right here, we're just going to make sure that the unit on the tile is not valid, because if there is a unit on the tile, well, it is not a valid neighbor because there's a unit on the tile. And that's how it looks. So I'm just checking to make sure that the unit on the tile is not valid right here before continuing the rest of the flow. And there's actually a second place where we have to check this condition also, and it is inside the isInputData valid right here, and we're gonna check at the end just right here. Right here we are making sure that the valid tile types contain the type of the current unit, so that's good, but we're also going to make sure that the unit on the tile is not valid. Just like that, so we are just making sure that the unit on the tile is not valid before returning true right here. Perfect, that should have fixed the problems. And as we can see right here, if I select my chicken and try to go through the current unit on the left, we can see that it goes around it. Perfect! So now it won't break the warrior because it doesn't overwrite its position on top of the grid. Great! And the opposite is also true. If I select my warrior and I try to go through the chicken, we can see that it walks around it. Perfect! That works as expected. Great! And there's one last little thing that I want to change before ending the video, and it is to make sure that this doesn't happen right here. I don't know if you see it, but the unit here, it looks like it's going up and down a slope and not really going up and down steps. So it looks a little bit weird, and also the unit is looking either down or up depending if it's going up or down. I don't think that's something that we want to. So I'm just going to fix that real quick before ending the video. And that's gonna be inside the BP unit right here. We're gonna go where the unit is moving, so in the timeline. But first I want to change a little something right here, because we don't want the rotation to affect the other axis than the Z-axis. We just want to orient the unit on the Z-axis, so what I'm gonna do is just split those two rotators and connect only the Z-axis, just like that. And now we can go to the timelines right here. And here I just gave myself a little bit of space because there's a bunch of things that are going to change. So the idea is when the unit is going up or down the steps, I just want to add a little jump to it. So the unit is going to jump on top of the step and jump down the steps. So that way it's going to be better, I think, visually than just the unit sliding down the slopes the way it's doing right now. So what we're gonna do is if the tile, the previous tile and the next tile are not on the same height, we're just going to add a little jump in the unit. So that's what we're gonna do, jump. So to check if the tiles are on the same height, it's super easy. We just have to compare both the location Z of both tiles, so the previous tile and the next tile, and just do a nearly equal just to make sure that they are on the same height or not. And then that's how I'm connecting it to the rest of the code. So using my condition, I'm doing a select. To select a float, I'm either gonna choose 0 if both tiles are at the same height. So if it's true, I'm going to select 0 right here. Otherwise, I'm going to use a new float track that we didn't create yet. We're gonna create a new float track right there that we're gonna connect into the false. And then that's going to be added on top of the previous transform location that we decided. So we are interpoling the location, and on top of that, we're gonna add the little jump in Z only. So now let's just go in the timeline, create the new track. So create a new float track right here in the top left corner. I named the track jump, and I'm just going to go connect it right away inside the select right here. So I'm gonna take the jump and connect it to the false just like that. And now we can go back in the timeline to do the curve itself. And we're gonna start by adding 3 new points in the curve, just like that. The first key is going to be 0, 0, so at the beginning of the curve, and the last key is going to be 1 and 0, so it is at the end of the curve, but without any height offset, so it's back to the normal level, which is 0. And now for the last key, this is the one that tells us the height of the jump. So for the time at which the jump happens, I'd say at the middle of the transition, so in the middle right here. And for the value, I'd say maybe something like 200 units. So the unit is going to jump 200 units in the air every time it's going from one step to the other. This value can change depending on the height of your grid, obviously. And now you don't really see the curve, so what you can do is click on the 2 little arrows here on the top left corner. So this is going to scale back the curve so you can see all the points. And what I'm going to do is select all of them and convert them to an auto. That way it's going to be a little bit smoother. Perfect. Now I'm just going to compile and go test that in game. And that's how it looks, and I think that's way better than what we had before. Now the unit seems to jump on the tiles. Great. Bon. I guess that's gonna be it for today, because this has been a longer video than I expected and I'm really tired, so I'm just gonna go sleep and I'm gonna see you in the next one. So bye bye!